we are going to start new chapter, that is capacitance or capacitor. This is last chapter of unit number 1. So what is capacitor? Capacitor is a body which can store charge, which can store electric charge. The bodies which has capacity to store electric charges are called capacitors, and this capacity to store electric charge is called capacitance. So capacitors are bodies which can store electric charge, and their capacity to store electric charge is termed as capacitance. So we will be studying all the related topics to capacitors, capacitance, how we can increase the capacity of any body to store charge. So bodies which can store charge can be conductors, because we have studied that conductors has ability to carry the charge. So practical way to handle a charge is to put it on a conductor. Thus conductor can store charge, but every conductor has maximum limit of storing a charge. Beyond that limit, if you give a charge beyond that limit, it will start leaking that charge into the atmosphere due to ionization of atmosphere around the conductor. So the maximum amount of charge that can be given to a conductor is limited. So if you give extra charge beyond the saturation point of that conductor, that charge will be lost. So we were in need to make a device, to make a body which has ability to store huge amount of charge. So these devices are called capacitors. So we can say capacitor is a special device which can store more amount of electric charge as compared to isolated conductor. Means single conductor cannot store much amount of charge due to its limitation, that it will start losing that charge, it will start leaking that charge into the atmosphere. So we need to make a special device. So we will be discussing about that special device, how to make a capacitor and how to increase its capacity. But before that, we'll be discussing about capacity of a isolated conductor, means a single conductor, how it can store charge. So for that, we will be starting with our topic, that is capacity or capacitance of an isolated conductor. Capacity of an isolated conductor. Now let us take a sphere carrying some positive charge. Let the positive charge carried by this sphere is Q. Let that charge be Q. Now we know when we give some charge to a body, to a conductor, whether it is a sphere or anything, it will develop some potential. Now due to this charge, the potential developed by this conductor is V. Now what is this V? The amount of potential developed by this sphere will depend upon amount of charge that is being given to this conductor. So the potential is proportional to amount of charge. Greater the magnitude of charge we give to this sphere, higher will be the potential that will be attained by this sphere. So potential attained by the sphere will be proportional to charge given to this sphere. Now if we want to remove this sign of proportionality, we have to apply a constant, and that constant over here is 1 by C. So 1 by C is a constant. So this is a constant. And C here is capacitance. C is capacitance. So we can note it down. Capacitance is denoted by capital C. So capacitance can be denoted by capital C. So from here we can calculate the value of C. C will be equals to Q by V. So capacitance is equal to charge over electric potential. Now coming to the units. SI units of capacitance are farad. Now what are farad? 1 farad will be equals to 1 coulomb divided by 1 volt. So 1 coulomb over 1 volt is a capacitance equal to a unit SI, that is 1 farad. So in this way we can even calculate the dimensional formula for capacitance. Although 1 farad is quite a large unit, instead of farad, the practically used unit is microfarad, as it was in charge. So in most of the question, microfarad will be used. 1 microfarad is equal to 10 raised to power minus 6 farad. That is same over here also. Next is method of finding capacitance of a conductor. That is the next topic. So firstly we will be using a conductor that is a spherical conductor. So in case of a spherical conductor, we will be calculating the capacity, the value of C, and we will be determining the factors on which this value depends in case of a sphere. So let us start. Let us consider a sphere which is given Q charge, Q positive charge. We are giving it a Q positive charge. Now due to this charge Q, let the potential attained by this sphere is 1 by 4 pi epsilon naught Q amount of charge over radius. So this is the potential attained by this sphere. Now we know from the previous formula C is equal to Q over V. So from here we can write V is equal to Q over C. Using this expression in potential, you can write Q over C is equal to 1 over 4 pi epsilon naught Q by R. So from here we get the value of capacitance equals to 4 pi epsilon naught R. So this is a expression for capacitance of a spherical conductor. So from this expression it is clear that capacity of a spherical conductor depends upon radius. Greater the radius of sphere, higher will be the capacity to store charge. So next we will be solving some numericals based on these formulas.